Okay, everyone. So I want to take just a few minutes and do a quick kind of a little more in depth on how to find the parts of the atom. Then I want us to practice drawing a couple of atoms, and then I want to show you ions and isotopes just a little bit more before I send you off to do your activities. So in the lecture, I gave you these three elements. And we found the number of protons, electrons, and neutrons. So for oxygen, because its atomic number is 8, that tells me that there are 8 protons. Since it has no charge, that means that it has 8 electrons. And then to find the number of neutrons, I asked the man, and that would be 16 as its mass number minus its atomic number is 8, which would give me 8 neutrons. So 8, 8, and 8, okay? For sodium, we found that the number of protons would be 11, and so the number of electrons would match at 11. And then to find the number of neutrons, we say 23 minus 11, which of course gives us 12, so we have 12 neutrons. And then finally, we had magnesium, which had 12 protons, and of course 12 electrons, and then 24 minus 12 gave us 12 neutrons. Okay, so this is how we would find the parts of the atom. Now, let's talk about how we draw a Bohr atom. So when we're drawing the oxygen atom, we start by drawing a nucleus. And inside the nucleus, I'm going to put the protons and the neutrons. And I'm just going to put an 8 plus for the protons and an 8 and my little symbol for neutrons, just a circle with a slash. And that's my first part of the atom. So the next part of the atom, I have to put electrons in. And electrons, we put them on these rings or shells that are found around the nucleus. And I draw them one at a time. And if you'll remember, to find out how many electrons, I tell people it's like a hotel. There's a maximum occupancy in each one of these shells. And when you fill up the floor on a hotel, you have to move to the next floor. And when you fill up the shell, then you have to move to the next shell. So the first shell, by doing 2n squared, we know that it's 2, 1 squared, which of course is 1. So that means that it can hold 2 electrons. So we're going to put them right here together, okay? Now, I always tell students that the number of electrons that can be held in a shell divided by 2 tells you how many seats are available. So if you say 2 divided by 2, that means there's 1 seat. So when one electron sits down, the only other place for the other electron to sit is to share that seat. They don't share the seat unless they absolutely have to, though. All right, so we've used 2. So that means 8 minus 2, we have 6 more to go. So let's see how many can go on our second shell. So we would say 2n squared. So 2 squared, of course, is 4 times 2. It can hold 8 electrons in the second shell. But we only have 6 that we're working with now. So I'm going to draw my shell. And let me show you how we're going to put these together. We start north, south, west, east. Other teachers will spread them out a different way. This is the way that I do mine. Electrons have the same charge, and we know that like charges are going to repel. And so they don't want to be around each other, so they try to get as far away as they possibly can. So that's 2, 3, 4, 5, 6 electrons that I have so far, but we need to have 8. So remember what I talked about with seats, okay? This had 8 electrons, but if you divide it by 2, that means that there's 4 seats available. Well, we've filled one person or 1 electrons in each seat, so now I need to go in and I need to pair them up. So just like I did before, north, south, and now I'm done, okay? So that's how you would draw oxygen. Let's look at sodium together. So in the nucleus, 11 protons and 12 neutrons. First ring holds 2. So I have 9 left. Second ring holds 8. North, south, west, east, north, south, west, east. So that's 10. So one more ring and one electron goes on there. And so it looks like this. I want you to pause your video right now, and I want you to do magnesium, okay? So pause your video. Okay, so this is what magnesium will look like. In this case, you have 2 electrons in the outer shell, which would make up your 12, okay? So this is how you draw a Bohr atom. Now let me show you a little bit about ions and isotopes, okay? So this time, when we find the parts of the atom, I want us to find the parts of the atom of oxygen with a -2 charge, okay? Now remember, there's one thing that never changes. That's protons. So oxygen has 8 protons always. I'm going to go ahead and put that 8. Now electrons, because this has a charge, the electrons have changed, okay? And I know that I normally have 8 electrons, but this -2 tells me that I have gained 2 electrons. So now, instead of having 8, I have 10. And then my number of neutrons will stay the same, which was 8. Okay, so let's do this one. Take sodium with a +1 charge, and I want you to find the number of protons, electrons, and neutrons for sodium. Pause right now. Okay, so you should find that there are 11 protons, 10 electrons because it lost 1, and 12 neutrons. The other thing that we learned were isotopes, and isotopes are where the mass number has changed. So in order to find an isotope, you're going to have to refer back to a periodic table, okay? So let's just say that I have fluorine -20. Now this does not mean that it has a -20. This big dash, big 20, tells me that this is the new mass number. So I'm going to ignore the normal mass number, which would be 19. So I would find my protons, which would be 9, my electrons, which would be 9. But then when I go to find my number of neutrons, I use the new mass number, -9, and I have 11 neutrons. Okay, you try this one. Lithium 8. Pause your video. We would see that it has 3 protons. It has 3 electrons, but the number of neutrons has now changed to 5. Okay? All right, so that's how you find your parts of the atom, how you draw a Bohr atom, and how you find the parts of an ion and an isotope. If you have any questions, feel free to email me and I'll be glad to answer them. Thank you.